Hello, welcome to our lesson on mathematical properties. So there are a bunch of mathematical properties, and some of them we've actually already looked at with some of our division and multiplication, but we want to make sure that we're okay understanding how the properties apply to all of the operations, and maybe not all properties, but the important ones that we're going to apply to what we do, and probably the more commonly used ones or seen ones. So um, basically what a mathematical property is going to allow us to do is rewrite an expression um, without changing its value. So the purpose would be to make it look different so that we can manipulate it in some way, and this becomes very helpful when you get to algebra, but it does not change its value. And when expressions look different but have the same value, we say that they're equivalent. So if they look different but they have the same value, again, we're going to call them equivalent expressions. That's one of the big goals with our mathematical properties, is what are the truths and things that we can use to rewrite expressions in equivalent form so that they look different but we're maintaining their value. For example, if you just look at the two pizzas I have here on the notes, if I had a pizza and you had a pizza, but I cut my and they're exactly the same size pizza. I cut mine into 8 slices, you cut yours into 4. Then if I'm sharing a quarter of the pizza, it's 2 slices. If you're sharing a quarter of the pizza, it's 1 slice. So even though I have 2 slices here, you have 1 slice here, that's the same portion or fraction of the pizza, and so we would say that those are equivalent fractions or equivalent portions of the pizza. Okay, so that's kind of the goal, and we'll definitely talk more about fractions later, but let's talk about the properties that we want to be familiar with. So the commutative property states that changing the order in which we either add or multiply will not change the meaning or the value of an expression. So we have a commutative property again for addition and multiplication. For example, if I said to add 5 plus 4, or I said to add 4 plus 5, and you could think about this on a number line, whether you start at 5 and then add 1, 2, 3, 4 to get to 9, or whether you start at 4 and add 1, 2, 3, 4, 5 to get to 9, it doesn't matter which route you take, you get to 9. So 5 plus 4 is 9, 4 plus 5 is 9. We can change the order in which we add those two numbers and still end up at the same place. The result is the same. And so no matter what your numbers are, we could call them A plus B. It will always be equal to B plus A. The order in which you add those two numbers will not change the value of the result. Okay? And that's true also for multiplication. If we were to multiply two numbers, let's say we took 3 and multiplied it by 8, whether I have 3 groups of, maybe I should have picked smaller numbers, but whether I have 3 groups of 8, so 8 here, 8 here, 8 here in this group, that's going to be 24 total, or whether I have 8 groups of 3, so 8 groups of 3, then I would have 1, 2, 3, 4, 5, 6, 7, 8. If these were 3 in each, and I'm not drawing this very well, but you get the idea, then I would still have a total of 24. Okay, so it does not matter the order that we add or multiply, the results will be the same. So again, for any number, A multiplied by B, the same product results if we take B and multiply it by A. Now, it's important to note not only that we have these properties for multiplication and addition, but that these properties do not apply to the other two operations. So let's take the same 5 and 4 and say we wanted to subtract them. So if I took 5 and I subtracted 4, then that would leave me 1. If I changed the order, not where the sign is, right, but just change the order of my numbers, so take a 4 and then subtract 5, I get a totally different answer, right? I get a negative 1. Because these are not the same, we clearly see that this is not what we would say commutative, not commutative. Okay, we cannot change the order in which we subtract and still get the same result. And again, for division, this will not apply. So if you took a number like let's not do 8 divided by 3, although it shows the same thing. Let's just make the division nice. Let's say I took 8 and divided by 4 to get a nice even 2. If I flip these around and take 4 divided by 8, change the order in which I divide, I don't get the same thing anymore. I get a half. Okay, so again, this clearly shows that division is not commutative. So we have a commutative property for addition and multiplication. We could change the order in which we add or multiply without changing our answer, but that does not apply to subtraction or division. Okay, and it's going to be similar with what we call the associative property. The associative property states that we can change the grouping. It's like what we're associating with, and then just for me, commutative property, I remember changes order. Changes order starts with CO, so does the commutative property. The associative property is changing the grouping. The grouping within an addition or multiplication problem, and it will not affect the value or the meaning or the final answer. An associative property is grouping. It's what are we associating with? Okay, how are we grouping these things together? So for example, you're going to see some grouping symbols when we apply this property. We might have something like, let me take some actual numbers here, like 1 plus, and then a group of 2 plus 3. So this is applying to addition. I can change the grouping. So instead of grouping the 2 and the 3, maybe I group the 1 and the 2. So 1 plus 2 and then plus 3, where I'm not changing the order. Notice it's 1, 2, and 3, and 1 and 2 and 3. I'm just changing the grouping. It really isn't going to affect the answer. So I could add these numbers in the group. The 2 plus the 3 would make the 5. And then I could add the 1 to the 5, and that's going to give me 6. Or I can regroup. Add the 1 and the 2 to make 3, and then add the 3, but I still get 6. And so changing the grouping, again, the way we associate the numbers in the groups for addition will not affect the answer. So for any numbers, again, let's say A plus B plus C. We can change the grouping, call it A plus B and then plus C out of the group, and we're not changing our answer. So that's what we call the associative property for addition. Again, keeping in mind not changing the order like we did with the commutative property, just changing the grouping. And this property will hold for multiplication as well. So if I was to multiply, let's say 2 times 4 times 3. So 4 times 3 inside the group there would be 12. If I took that 12 and then multiplied by 2, I would get 24. I could change the grouping. So group the 2 times the 4 and then multiply the 3, and I'm going to get the same answer. So inside the group, the 2 times the 4 would give me 8, and then 8 times the 3 still gets me 24. So not changing the order, again it's 2 times 3 or 2 times 4 times 3 in both cases. We change the grouping, doesn't affect the answer. So for any numbers, A times B times C, then A times B times C in that new group, going to maintain the value of what we're looking at. So again, it's important to note that this applies to addition and multiplication and that it does not apply to the other two operations. So again, let's say we took subtraction. So if I had, let's go 1 minus a group of 2 and then minus 3. And then I change the group. So 1 minus 2 and then minus 3. Oops. Okay, so in this one, if I worked inside the group there, 2 minus 3 would be a negative 1, and then I would have 1 minus that negative 1, which is going to leave me a 2. Here, if I work inside the group, 1 minus 2 is going to give me a negative 1, and then if I subtract 3, then I end up with a negative 4. Totally different answers, again showing me that subtraction is not associative. And I better not abbreviate that one. Okay, not associative. We end up with two different things that are not the same. And then this is not going to apply for division either. So with a division problem, maybe we take, I don't know, 10 divided by 2 divided by 1. So with this group, 2 divided by 1 in the grouping would be 2. And then if I take the 10 and divide it by that 2, then I end up with 5 for an answer. Or if I take my 10 divided by 2. Oh, maybe I chose a not good example here because it actually works out. So I guess this is a teachable moment here. There are times where we can change the order that we're uh, doing some of these operations and end up coincidentally with the same result, or in this case, because I chose a 1, which was not a good idea. Um, but in order for something to be true, it needs to always be true. So if there's just one instance where it isn't, then it's not true. So it's like if there's a counter example, let me change my example so that this actually shows that it's not going to work. So maybe we take 10 and divide it by 2 divided by 2 like this. So in the grouping, 2 divided by 2 makes 1, and I take the 10 and divide it by 1, and I get 10. I change the grouping, so 10 divided by 2 and then divide by 2. In the grouping, 10 divided by 2 makes 5, and obviously when I take the 5 and divide by 2, I get 5 halves. So the first example I chose was not a good example. It actually showed that, or made it look like division was associative. Again, in order for it to be true, though, it has to be something that's true all the time. And as soon as I change my example using some different numbers, you can see how it doesn't hold. So again, these not being equal tells us that this operation is not associative. Okay, so good teachable moment there. All right, let's look at a couple more properties. So the distributed property, I put here that it's the most used property. I don't know that that's necessarily true. It's just that some of the other properties like the commutative and the associative, we sort of use those instinctually and we don't sometimes see the use of them, we just do it, where this one we physically see quite often. So the distributive property actually involves a couple of operations at the same time. It's looking at multiplication and addition or subtraction within the same problem. And again, with this property, you can change the way something looks, right? Rewrite it without changing its value. So whether you do the addition or subtraction first and then the multiplication that's going to be in this problem, or vice versa, the result is going to be the same. So let me show you how this distributive property looks. So again, you're combining addition, or this could be subtraction, with multiplication. Okay, so let's say we added first. If we were in the grouping symbols and we added first, the 2 plus the 5 is going to make 7. And then we did the multiplication of 4 times that 7, we get 28. Now, if we wanted to multiply first, this is where we're actually using this property, this distributive property. To multiply first means this 4 has to multiply to each of the terms inside of our grouping symbols. So we're going to multiply it to the 2 and multiply it to the 5. So again, this is how our distributive property works. We take the 4 and multiply it by the 2. We take the 4, we multiply it by the 5. And we're adding our results. So we do the multiplication first and then do the addition. Well, the 4 times the 2 gives me 8. The 4 times the 5 gives me 20. I add those and I still get the same answer, 28. So whether I multiply first, which is where we're actually using our distributive property, or do the addition, or if it was subtraction inside the grouping symbols and then multiply, we end up at the same place. So again, our distributive property says if we have something like a times b plus c, that would be the same as a times b added to a times c. And that could be subtraction and it would work the same way. So if I had a times b minus c, this would be a times b minus a times c. Now if you're thinking, if the order doesn't matter, what's the purpose? Again, this becomes very helpful when we get to like algebra, for example, and you don't need to worry about knowing how to do this, but if I had something like 3 times x plus 2, for instance, the option to actually add first isn't possible because x and 2 aren't like terms, so then the only option would be for me to distribute or do that multiplication first. So again, some of these properties we use instinctively, some of them really help when we get to higher levels of math, but this one we do see quite a bit, so hopefully that's familiar. All right, let's talk about one last one. That's the identity property. So the identity property, again, this is sort of instinctual. We kind of use this without like seeing it all the time, but it involves performing an operation on a number that leaves its original value unchanged. So again, we're not changing the original value, which means we're not changing its identity. So It's the same concept, right? We're rewriting something without changing its value, but this time we're performing an operation to not change the value. So we can actually apply this to all four of our operations with addition, and then let's do subtraction, and then we'll do multiplication, and then we'll do division. The identity property, like what you're asking yourself is, what can I add to a number that won't change its value? Well, I can add 0. I'm not going to change the value of a number when I add 0, thinking about your number line going 0 places away. And so that's what the identity property looks like for addition. Whatever number I have, let's call it A, if I add 0, my number, my value, is not changed. So we say the additive identity is 0. I can add 0 to any number and not change its value. And the same for subtraction. If I have a number and I subtract 0, again, not changing the value of my number. And then for multiplication, what could you multiply a number by without changing its value? Would be 1. If I took a number, any number, and multiplied by 1, it's not going to change the value of my number. So we say the multiplicative identity is 1. And same for division. If I took a number and I divided it by 1, I'm not going to change its value. I still have my number. Okay? So adding 0, or adding or subtracting 0, multiplying or dividing 1, not changing the value of our number. That's what we call the identity property. And again, it seems kind of silly, like, well, what I need to add 0 for, what I need to multiply by 1 for. We actually use this in some basic operations, but it becomes very useful in algebra. We use special forms of 1, special forms of 0 to manipulate expressions. Okay? But hopefully that gives you a good idea, or just reinforces some of the properties that we see and use. Again, these will be somewhat helpful for us as we start moving into operations with integers. But I think you got enough to go on for now. So if you have any questions, then reach out. If not, take care.